Good morning, dear students. Let's start new periodic property, that is electronegativity. What is electronegativity? Actually, electronegativity of an element is the tendency of its atoms to attract the shared pair of electrons towards itself in a covalent bond. Here, for electronegativity, we have to consider covalent bond. Now, consider the formation of a covalent bond between two similar atoms. As you know that covalent bond can be formed between similar atoms HHOONN and dissimilar also HCl, H2O and others are also there. So consider here the formation of a covalent bond between two similar atoms of a molecule like hydrogen. In this molecule, the electron pair participating in the formation of covalent bond is shared equally. Okay, is shared equally by both hydrogen atoms. That is, the electron pair lies exactly in the center of the molecule. On the other hand, consider the formation of a covalent bond between two dissimilar atoms of a molecule like HF. In this molecule, the electron pair participating in the formation of covalent bond is not shared equally by the two atoms. With hydrogen and fluorine, that is, the electron pair lies near to fluorine atom than to hydrogen atom. The reason for this unequal sharing of electron pair is given by saying that fluorine atom has a greater tendency than hydrogen atom to attract the electron pair shared between them towards itself. In other words, fluorine atom has greater electronegativity than hydrogen atom. Thus, the electronegativity of a bonded atom is defined as its relative tendency, means its ability to attract the shared electron pair towards itself. Okay, it is denoted by symbol psi. CHI we say psi, and this is the denotion of electronegativity. Suppose I say that A is an atom, so electronegativity of A atom will be psi A. Okay. You can see that electronegativity of any given element depends upon the two factors. Number one, state of hybridization. An sp hybridized carbon is more electronegative than sp2 hybridized carbon, and this in turn is more electronegative than the sp3 hybridized carbon. Oxidation state of element. The electronegativity of an element increases with the oxidation state of the element. When we will see the electronegativity, you will find that fluorine is most electronegative element. After fluorine, oxygen, after oxygen, nitrogen, then carbon, then hydrogen. So this picture depicts that how the shared pair is being taken by one element. This only is electronegativity. If electronegativity difference is between 0 and 0.3, your compound will be a non-polar covalent compound. Suppose just take the example of hydrogen, H. No, whatever we are having, electronegativity. Suppose O2 molecule is being formed. Okay, oxygen is very electronegative, but it is not polar. Why? Because both atoms have the same electronegativity. When you will try to find out the difference in electronegativity, as you know, for oxygen it is 3.5. 3.5 minus 3.5, you will get 0. So there is no difference in the electronegativity of both the atoms. So non-polar, or you can say that these are few covalent compounds are have zero electronegativity. Okay, so they will be termed as non-polar covalent compounds. Atoms are approximately equal in electronegativities. Most common diatomic molecules and hydrocarbons are mentioned here. Here one list is given where you can see the electronegativity of few elements with its atomic number. Fluorine atomic number 9, exact electron, you will find that somewhere it is written 4, but here it is written 3.98. Actually the electronegativity is determined by different scale, Pauling scale, Mulliken scale, and these scales, when we do the calculation work, so we can get a little bit approximately equal to the value which is being taken or used by all of us. 4, if I am saying, means when we will do that, try to find out in on Pauling scale or Mulliken scale, we will find a little bit different values. Okay, but it will be nearly equal to the value which we are, which we, means this is, one is observed value and other is experimental value. After experiment, we just get a little bit difference in the values. Oxygen 3.44, chlorine 3.16, and like this only. Now what is the application of electronegativity? First I will like to discuss about the trend in the periodic table. Here one periodic table is mentioned here with three colors: green, yellow and red. Green elements, those are not green elements, but they, with the green color, the elements which are shown, they have low electronegativity. Yellow one will have medium electronegativity, and red one will have the highest electronegativity. So by this you can see that variation in group, electronegativity decreases on moving down the group. Okay, in a group, when we will start moving in a group, we can see that it is decreasing. And variation in period, the value of electronegativity increases from moving left to right in a period. What is the importance of electronegativity? Nature of bond between two atoms. If the electronegativity difference between two combining atom is 0, the bond is purely covalent bond, and the bond is covalent and it is non-polar. H2, Cl2, N2, these all are non-polar. If the difference means, as I have said, that it is denoted by psi A minus psi B. Means we are taking the difference of two atoms. If it will be small, the bond is polar covalent. 1.9, if the value comes, the difference, if we will take out, and it will come 1.9. A and B, two atoms are there. The electronegativity difference is psi A minus psi B. Okay, if it is 0, then means covalent compound, but it will be non-polar. If the value is small, then our compound will be polar covalent. If we will get the value of 1.9, if this difference is coming 1.9, the bond is 50% covalent and 50% ionic. And if we get the value greater than 1.9, if the value comes greater than 1.9, the bond is more ionic and less covalent. Okay, and percent ionic character and percent ionic character can be calculated by Henny and Smith equation and Pauling equation. Okay, a simple formula is there. If you want to know, I can tell you about Henny and Smith equation to find out the percent ionic character. This will be equal to 16 psi A minus psi B plus 3.5 psi A minus psi B square. This is your Henny and Smith equation. If you would like to see the Pauling equation for percent ionic character, it is equals to 18 psi A minus psi B to the power 1.4. Okay, with this we can calculate the percent ionic character. With the help of electronegativity, we can find the acidic and basic character of oxides. If psi O minus psi A, O is your electronegativity of oxygen and A is the other atom. If it is large, then oxide is your will be basic in nature, for example sodium oxide. And if this is small, okay, if psi A minus psi B, the difference between oxygen and the other atom is small, the oxide will show the acidic character such as sulfur dioxide. Okay, psi O is your electronegativity of oxygen, and psi A, if we are taking this, then psi A is your sodium, and if we are considering this, psi A is your, we can write psi S or psi Na. Okay, it is a generally it has been said that A. So this was all about this chapter. When you will find the valency and oxidation state, need not to discuss about it again, because complete chapter we have studied about it. Your chapter 8 redox reaction, there we have seen oxidation state, how to balance the equation, more whatever is given in here, more we have studied in that chapter. So to find out the nature of oxide in a period, the nature of oxide varies from basic to acidic. Okay, and one more property, if you remember the anomalous properties of the second period elements. Diagonal relationship. The similarity in the properties of the elements placed diagonally by each other in periodic table is called diagonal relationship, and this can be seen in the elements of period 2 and period 3. Group 1, 2, 13, 14 you have to write. Period 2 and period 3. Group 1, Group 2, Group 13, Group 14. In Group 1, lithium, sodium, beryllium, magnesium. Group 2, boron, aluminium group 13, carbon silicon group 14. We can find a diagonal relationship between lithium, magnesium, beryllium, aluminium, boron, silicon. The similarity in the properties of the elements. Okay, the diagonal relationship among various elements in the periodic table may be attributed to following reasons, such as their charge radius ratio is nearly equal, their electronegativity is nearly equal, their polarizing power is nearly equal. So this was all about this chapter, children. Small, easy, and you have not studied, you have revised this chapter. So related to it, no extra questions are there. Whatever is given in your book, you can go through it. The short questions, descriptive questions, and then multiple choice. Multiple choice question, you should go for the last. Okay, because for that every concept should be very clear. Okay, in writing short or detail, you can write left and right, but in choosing the correct answer, exact you have to write, and for exact mm, um, writing the answer, the concept should be very clear. So objective questions you will go for them to solve in the last. Okay, so this chapter is over. I will come here again in front of you all with my new chapter. I think I'll mention the chapter which I am going to start after this. Okay, thank you so much, children.